Okay, let me introduce the second speaker, Professor Simon Mohamed Mazharul Haque is a professor of the translation engineering at the Queensland University of Technology, QUT, in Australia. He's a specialist in econometrics and artificial intelligence applications in translation engineering and traffic safety. Today, he'll talk about his paper titled The Impact of Connected Vehicle Environment on Driving Behavior and Safety, a driving simulator study. Professor Simon, please turn on your camera and share your screen and start your presentation. Okay, please make the screen full. Okay, perfect.
Is it working?
Yes, perfect.
Okay, thank you, Professor Lee. Thank you for the nice presentation. So here today we'll be talking about the impact of the connected environment on driving behavior and safety. So I am presenting this research on behalf of my research team, and it has, of course, as I mentioned here, Dr. Yasri Ali, Dr. Anshuman Sharma. When we did the first study, they were our PhD students. Now they have become the faculty member in various places. So, and I'll be talking about that our research on behalf of the whole team. So let's start with the background first, that why we are all fussing about this connected and automated vehicle, because of the transport externalities that we have. In Australia here, we have more than 3 Australians are killed daily in road crashes. And over a year, we have around 40,000 of hospitalized injuries. Another important externality is the estimated congestion cost. So in Australia, it's about $10 billion a year. So technological innovations like connected and automated vehicles are bringing the promise that they would be able to solve these problems. And some experts believe that they will solve the problems over the night, but I'm in the other side of the group, which is pessimistic group. We believe that it will take time, as Professor Haque has also presented that it is so important to understand the interactions between the automated vehicles and the traditional vehicles in the traffic, because that we cannot change all the vehicles and everything over the night. There will be a considerable amount of time period where we'll have a mixed traffic. Okay, now there are two concepts here. One is a connected vehicle, another one is automated vehicles. Okay, what is connected vehicles? Connected vehicles have that represents the capability of the vehicles that can fetch information from the neighborhood vehicles as well as from the infrastructure and offer those information to the driver, so the drivers can make informed decisions of various traffic events or driving events. On the other side are the automated vehicles. Automated vehicles represents of course, that how much of your driving task you can assign to the machine. And as Professor Huang Helai mentioned in his presentation early this morning, that automated vehicles have various levels, and we are seeing that we are receiving publications in AAP, and they are trying to understand the safety impacts of automated vehicles of various levels. Now, coming back to this point, that if you think about the connected and automated vehicles, at some point, I strongly believe that they will come together, and they will then you become a connected and automated vehicle. At this moment, if we look at the industry or look at the vehicle manufacturers, we can see that those capabilities are being developed and over the time gradually. So and at some point, connected and automated vehicles will come together, we believe, but we have a long journey ahead. So here, in the scope of this study today is limited to the connected vehicles. Okay, that if we provide information about the various driving events in advance, how drivers response to those events, a response to those driving assistance or driving aids. So that will be the main research question that we are doing. So, and what are the motivation in the current research? I think, as I said, that Professor Huang has really presented a rigorous of investigation of the detail of the research, road safety research that is happening the road safety regime. But here I'm mainly talking about that research being done in the area of connected and automated vehicles. In the last few years, of connected automated vehicles are quite new, and we all know that they are coming, but for the researchers do not have access to the sufficient data that are required for to answer lots of scientific research questions. Okay, what has happened in the past? We have seen the numerous papers being studied with the numerical simulations, and it has been published in various journals, in various transportation journals, published to Elsevier and other publishers. But the main problem of the numerical simulations is that they don't consider the human factors, actually how humans are interacting with whatever technologies we are offering to them. First thing, and for the research, when it comes to the driving simulator, I'll be talking about the capability of the driving simulator more in a minute. And when we see the lots of research being done, of course, the driving simulators have been established to understand the mainly psychological research and the human factor research. And it has been tested for various driving tasks. We give some goal-driven task, and we see that we think that actually that if we would like to understand that how drivers behave in that environment, we need to offer an environment rather than a particular task. So that's the main another motivation for us, that we want to expose driver in a connected environment. I wish we could do it in a real world, but of course the ethics will not allow, and it's costly. So we are going with the driving simulator. So, and again, I'll be talking more about that. So to clarify that what we are trying to do in this article, we are trying to examine the effects of the connected environment on driving behavior and safety. And we are at first in this article, we try to answer two broad questions before we go details. So whether driver can improve their driving behavior towards safety through a connected environment, that's the first thing. And the second question was that what will happen if there is any communication delay or communication loss in the connected environment, and how it is coming, because if you are connected with the IEEE kind of journals and those people who are developing these connected vehicle technologies, so there have been already discussion that that there might be a situation where you can lose the communication with the vehicle, or all the messages or instruction you are giving to the drivers might be delayed. So we would also like to see that what will happen if it happens in the real world. So here for this experiment, as I mentioned, that we have used our driving simulator, advanced driving simulator. This advanced driving simulator is our QT's CARS-Q advanced driving simulator. I'm pretty sure that if you are not familiar with what is CARS-Q is the Center for Accident Research and Road Safety, Queensland. And it is one of the top road safety organizations in the world, and have contributed many papers in AAP and other road safety journals. So I'm fortunate to be affiliated with CARS-Q for sure. And this simulator has the capability of 6 degrees of freedom. And for those who are working in the area of driving simulator, that it actually can produce the driving environment as close to reality, if not full. And it can move and twist in three directions, in X, Y, Z directions, and that's why it is and is responsive to the pavement irregularities, for example. So it really gives a good realism of the driving, and it is covered with a 180-degree field of view with the 3 big projectors. And here I have put some snapshots of the different control systems and the shots of our driving simulator, which has been tremendously helpful of doing many research in the area of road safety. And this is the first time I'm talking about that we have used this driving simulator to do research from the transportation engineering point of view, because many research in the driving simulator has happened from the psychological point of view. And we have actually demonstrated that driving simulator can be used for many transportation engineering research, and the models we developed from those driving simulated data can replicate the real world field data. And of course, that is off topic today, but we can talk more later on. So in this driving simulator experiment, what we have done, we have simulated 4 driving conditions. One is, of course, traditional driving, when it is a normal driving, when we did not provide any kind of connected communication or any kind of assistance to the driver. Then we have the second one is the perfect communication, means that the communication was working perfectly, and we have provided we provided the assistance to the driver or driving aids in time. And we have the other 2 scenarios, which is communication delay. In this case, that whatever assistance we provided to the driver was delayed by 1.5 seconds. And why 1.5 seconds? Actually, we have tested of various delay scenarios and found that this is the 1.5 seconds after which we see that there are some changes in the driving behavior start to happen. And communication loss in this scenario, actually the communications are lost time to time. So as I mentioned in the beginning of my presentation, that we wanted to give drivers an environment rather than any kind of car following or any kind of task, So we just thought that, okay, what a typical driving episode look like. Let's say if we consider that if a typical Australian coming from home to work, and what are the typical, if by driving, for example, that what are the typical roads? They might be traveling a little bit of motorways, and they need to travel in a suburban or urban conditions, So we try to replicate some important events that of course, then you need to do car following, you are having some kind of lane changing instances, you need to interact with the pedestrians to the pedestrian crossing, you might need to interact with the traffic lights, of course, that, and the speed limits have been changing over the time, and where how you are responding to them. Okay, so these are the major the main traffic events, like a typical routine driving event we have simulated in our connected environment. Then we exposed our participants over there, and the total length of the driving road was around 10 kilometers. Where we have a section of, as I mentioned, section of motorway and urban suburban conditions, and thank goodness this CBD area, which is the Central Business District area, actually included a detailed simulation of the Brisbane Central Business District with all the buildings, everything as exactly as the same as our Brisbane city. I must say, beautiful Brisbane city, and so we have created that whole connected environment close to the reality, so that the driver feel that they are in a kind of their known environment. And I'll be talking about more that what are the different designs that we have made for the different driving events. So we had altogether 78 participants, and that participants we purposefully avoided convenient sampling, like they are not our university students. So we have recruited them carefully, one by one from the driving population, and we have advertised beyond the universities, the other train stations in the Brisbane city, in the different areas, and recruited them carefully. And we had 78 participants altogether, an age range of 18 to 65 years, and that age distribution closely resembles the age distribution of Queensland population. And we have around 36% of the female, and their average driving experience of 12.2 years. So you understand that they are quite a kind of experienced group of drivers. So what are the connected environment design? Okay, in the connected environment design, we try to simulate the connected environment and try to provide those information to those drivers which are not visible directly by the naked eye at the time they're driving, right? So of course, that we have provided some warning messages, we have provided some informatory messages, and we have provided some advisory messages. For the warning messages, for example, that this is the first figure that you are seeing here. This figure represents that the always on the screen to the driver. So we have the information of the current speed limit, and it will flash if the driver exceeds the speed limit. And this information is given the speed of the lead car, it means the speed of the leader car, and spacing from the lead car. the spacing. This is always given also there. You know, in case of any kind of multi-lane driving, if there is a lane changing opportunities available, so it becomes something like that, depending on change the lane. We have provided the information and leave it to driver and let them to take a decision whether they want to change the lane or not. And again, of course, the left side, this is again given the speed and the spacing to the leader car. For in the city area, for the traffic events, we have given some other advisory messages. For example, for some traffic lights, we have given that if the traffic light was changing from green to red, we provided in the information at much earlier that for something like red light in 5 seconds, you know, so when they are at least 5 seconds away from the intersection, we have provided the information to the driver and wanted to observe what they do. Same thing we have done for the pedestrian crossing. There are multiple pedestrian crossings in the scenario. There are some of the pedestrian crossing where there are pedestrians, and of course that and we provided information if there is a pedestrian crossing on the pedestrian crossing, and we provided the information much earlier than we see something like watch for pedestrians. I remember we given that information around 6 seconds before the pedestrian crossing. How should I clear it? Okay. So, and before now, I will start talking about our different driving simulator events and some of the results, preliminary results that we have got in this paper we have discussed, and that's the main topic. But of course, that we have done detailed investigation for each of these traffic interactions through other scientific research articles. But here I have not covered here. There are a couple of important points that I did not cover here, but I would like to mention here before I go to the describing the results. First of all, for any driving simulator experiment, of course, we have followed the standard protocol, and we have randomized the driving events. We have randomized the appearance of the driving routes or driving conditions. So they are absolute minimum, which I ensured to save time. I didn't go there. And one of the particular aspect of this whole experiment design is that we have given attention to the detail. So each of the traffic events and the driving road have been constructed. Of course, the road design have been constructed following the Australian road design standards and Brisbane CBD, as I mentioned, that is the actual Brisbane CBD, and all the traffic events we have created. They have created after lots of trial and error, and to make sure that it resembles the actual traffic events. So here I'll be talking now about about driver performance and compare between the connected environment and the baseline conditions and some cases in the perfect communication and communication loss, you know. But please note that we could not have the communication delay and communication loss for the city areas because of the quickness of the event, but we simulated them for the traffic events along the highways. And for the now, let's start talking about the car following first. In the what we have simulated or we have included 2 car following scenarios, one along the motorway and one in the urban road. And along the motorway, the speed limit or the leader car was the speed of the motorway was 100 km per hour, but the speed of the leader car was maintained 85 km per hour. And for the city events, the lead car maintained a speed of 40 km per hour, and I would like to see that how driver perform their car following scenario. But as I said, that we never ask driver to do whatever they are driving from the start to the end as if they are going to a particular road and particular destinations, and the destinations have been guided through some road furnitures along the road. And this is a video of the car following scenario that is given by a particular driver, and you can see that there's all of information been given to them, and if there's a lead car braking, information provided to the driver here. And what we found that actually that in the connected environment, when the information being presented to the driver, they maintain a higher safety margin, and speed limit exceedance warning was lower in the connected environment. And so this is the first thing, so the good sign of our connected environment. Then we went to the lane changing events. So again, we have done a simulated event about discretionary lane change, and when a lane changing event started, drivers were given or lane changing opportunity was available. Drivers were given this kind of information, that what are the distance to the following vehicles, and they can make their lane changing decision. And we found that actually when we have provided those information, lane changing distance to the driver, it improves safety significantly. Okay, they are maintaining a bigger gap between the vehicles, and the direct for those who are aware is a deceleration required to avoid crashes, which is a conflict method that indicates safety. Okay, in that conflict method, we can found that, of course, that when we have provided the information to the driver and the connected environment, actually the direct value was less, which means that they improve the safety. And for the communication delay, which is this one, communication delay, then of course that when there's a delay to the communication, we found that there is again some they deteriorate safety a little bit, and in the communication loss, again they deteriorate safety further. So similarly, we have created a scenario for the mandatory lane changing, which means that we have blocked one of the lane in the scenario, and following the standard of the temporary work zone control. And we wanted to see that what drivers do, and they have been offered around these 5 gap sizes, so they have an opportunity to pick a gap, or they have the opportunity not to pick any gap, depending on whatever they're comfortable with. So this kind of message has been activated when they reach to this position. And again, similarly, we have observed that they, again, for the mandatory lane changing as well, so they actually select the relatively larger gap when they know that what is coming. And we have observed that many drivers wait for their comfortable gap to occur, because you have now the luxury of the information that what is happening along your adjacent lane. Interaction with the pedestrians along a pedestrian crossing. So you can see that on the video, that on the bottom left corner of my slide, that we provided the information to the driver when the drivers were around 6 seconds away, and the pedestrians were not visible at all by the naked eye. So and when we have provided the information, of course, that we found that they responded to the pedestrian very well. They maintain a higher time to collision with the pedestrian, which is an indicator of improved safety. And interaction of the traffic lights. So we had another traffic event that we have we designed here, that in the CBD. By the way, as you can see, that for those who are not in Brisbane looks something like that in the CBD area. So when we have provided information about the traffic light around 5 seconds away, that there will be a change in the traffic light, and we observed drivers what they do. And we found that drivers are more cautious, of course, when they approach to the intersection. And they you can see comparison between the baseline and perfect communication. You can see that the yellow light running frequency was lower for the drivers in the perfect communication condition. But unfortunately, we could not test it for the communication delay and communication loss for this scenario. So in conclusion, for the whole experiment design, we found that in the connected environment, they maintain a higher safety margin during the car following, and they in the perfect communication, they violate the speed limits less often. Apart from the lane changing with a higher safety margin, they are more prepared to give way to the pedestrians, so they run yellow light less. But when we have the communication loss and communication delay, actually that it deteriorates safety as expected. So you can see that connected environment, those information being given to the driver brings lots of promise, because at the beginning of the experiment, we have been questioning ourselves whether those information will increase their workload or deteriorate their driving performance, or whether those information, they will take it positively and improve their driving performance. So it looks like they have actually improved their driving performance based on the information being provided to the drivers. But these are our preliminary results from that comprehensive driving simulator experience that we have done. As I mentioned in the earlier of my presentation, that this this whole experiment design with lots of traffic events actually that that my team here in QUT, they have been working in developing various traffic flow models, various traffic safety models, you know, and we found that actually overall it's going to the positive towards the safety is one thing. Second thing that we have quite clearly established that driving simulator is a powerful tool for not only doing for psychological research, but also for doing for lots of traffic engineering research. But there is a big but here, but that experiment design and the details of the traffic interaction that are designed, that has to be done very carefully and so that it reflects the actual driving conditions as much as possible, if not all. And for example, we have found that car following models and the lane changing models that we have developed from the simulated data, it can quite well replicate the real world trajectory data like NG-SIMS and others. So that are the two key messages that I would like to provide with this presentation. One is driving aids are helpful for the drivers to improve safety, and driving simulators actually represents a viable tool for us in conducting various research, because you know that connected and automated vehicles are coming at this stage. Getting the field level data is becoming increasingly difficult, you know, but we need to answer many research questions before we expose them in the road traffic environment. Of course, as soon as we are going into the field data collection, like there are lots of experiments around the world is happening to the natural electric driver. Here in Haque is doing lots of detailed investigation of various connected vehicle interactions in the real world scenario through field trials. So those data will become available at some point, and then it will give us a chance to investigate more on this topic. So thank you so much for listening, and over to you, Professor Lee.
All right. Thank you very much. It's a very impressive work. And I got several questions, but I chose two. The first question is a fundamental question about the driving simulator itself. So how to ensure that driving simulation experiments maintain the same driving behavior in the real world, especially CAB does not exist right now.
And that's thank you, Professor Lee, and that's an excellent question, and that was the main message that I wanted to convey right now. That we all believe that when we go to the driving simulator, our driving is not as the real world driving, you know. So and it is not a good idea to compare the driving parameters of the driving simulator and the real world. But you just note that here we are talking about the differential effect. Differential effect means between the normal driving condition and the perfect communication, and they're both in the driving simulator scenario, right? So that differential effect is important to understand from the driving simulator. Of course, that differential effect may be slightly different from the real world, but as we are conducting some research, we say that that differential models that have been developed from the real world trajectories. So when you talk about the driving simulator experience, you always put that as a tag, but at the same time, we are talking about the differential effect, not the actual effect of the driving.
Very good. And the second question, it is also a fundamental question about the sample selection and sample size. You use the 78 the participants. Do they represent the driving population? And also, do you need to control the social demographic characteristics of the participants?
And that's a brilliant question. I cannot read the name of the person who has asked this question, but that's a very good question, and that has been the questions when we started to recruit our population, even before when we started to design the experiment. First of all, at first we did a comprehensive study that, okay, around the world of the driving simulator research, whatever happening, what is the sample size that we have been using over the years. And for some reason, we found that there is a magic number, which is 36. We always, for some reasons, across the globe, many studies have used 36 participants at the sample site, but you know that driving simulator sample is very expensive, because you are going to recruit a person, come to drive and give you around 1.5 hours of their time, and you maintain their health and well-being during the time, and entertain when they are in your lab facility. So it is a costly, it's a timely, it is a costly sample. It's not a kind of an easy sample. So cost is one point. So we try to make sure that, okay, we try to maximize the number of participants, and we did, again, for the sample size, we are doing some testing right now, and that at what are the sample sizes required. But unfortunately, I don't have a detailed answer right now, because we can see that for car following scenario, for example, around 30 samples is good. But if you go for other driving events like interaction with the traffic lights, 78 participants were not enough, and probably we needed more. So again, it depends on what kind of traffic events we are talking about. So we are learning from the experience. And second thing is the socio-demographic details of the participants to have a balanced sample. Yes, we have strongly controlled that. And we wanted to make sure that we have a representations of the different driving demographics for the different age groups and the gender groups. Thank you, Professor Lee.
Okay, very good. All right, thank you again for your presentation and answer to the question.
No problem.